Hello everyone. Welcome to Science Free. Our aim today is to find the resultant and direction of some concurrent coplanar forces. So as you can see, we have three forces which acts at a point which are pulling in different direction, and we want to find the magnitude when these three forces are added together. So what we can do now is to construct a table and place these forces in their vector components. The two formulas which we will use are F cos theta and F sin theta. We use F cos theta to find the horizontal forces which is in the x direction, and we use sin theta to find the vertical forces which is in the y direction. For A we have a force of minus 5.4 Newton, which is acting at an angle of 42 degrees from the horizontal axis. If you are wondering why the force for A is negative, that's simply because it is acting in the negative x direction. So let's calculate the horizontal axis of the force for A. For A we do minus 5.4 cos 42 degrees, and that is equal to minus 4.01 Newton. Let's calculate B. We do 18.2 cos 35, which is equal to 14.91 Newton. So far C, there's no force acting in the x direction, so we leave that blank, or we could just write 0. Let's find the total. Calculating the force for the vertical axis which is in the y direction. For we have 5.4 sin 42, which is equals to 3.61 Newton. For B, we have 18.25 sin 35, which is equal to 10.44 Newton. For C, we place only the 8.2 Newton in the table because the sin of an angle is just 1. So in this case we would get back the 8.2 Newton. We can now find the total for both x and y component forces. We now use the Pythagoras theorem to find the resultant of the components. The formula is r equals to the square root of the resultant component force of r squared plus the resultant component force in the y direction squared. For the total component force of Rx we have 10.9 Newton, and for the total component force of Ry, we have 5.85 Newton. We now plug them in the formula. We now use the Trig Ratio to find the direction of the resultant. And the formula is the inverse of tan times the component of Ry over the component of Rx. We know both values, so we now plug them in. So for Ry we have 5.85, and for Rx we have 10.9. After calculation our answer is found to be 28 degrees. So guys, this is our second vector question, and I would advise you to please pause the video and attempt this one to see how much you are understanding. So similarly we need to resolve these component forces in their vector components. And again we use these formulas to work out the total component forces. So again we set up our table for the values to hold. Section 10 will contain the horizontal values, and section Y will contain the vertical ones. So the force at A is 16 Newton, and it acts at an angle of 60 degrees. To calculate it for the horizontal axis, we do 16 cos 60, which then gives us 8 Newton. So for B, we just place its original value back in the table because it lays on the horizontal axis to east, which is in the first quadrant, and it is not placed at an angle. C is not acted on a horizontal point, instead it acts in the negative y direction, so we leave it blank. So D equals a force of 50 Newton and is at an angle of 28 degrees. Because this force acts in the negative x direction we treat it as negative. So we do negative 50 cos 28 degrees, which is equals to 44.15 Newton. So we can now find the total component force. And that equals to minus 26.15 Newton. Moving to the y direction. So 16 sin 60 gives us 13.86. B is only acting in the horizontal direction, so we leave this section blank. For C we have 25 acting at an angle of 90 to the negative y direction at 90 degrees, and the sin of 90 is just 1, which will give us back a value of 25 in the table. But we also put a negative sign to represent its direction. Now to find the component force at D, we do minus 50 sin 28, which is equal to minus 23.4. And it's time for us to work out the total component force for the y direction. So 13.86 plus negative 25 plus negative 23.4, this equals minus 34.61 Newton. And now to find the resultant force we use Pythagoras theorem as we did at one part in the first video. For the total component force in the x direction we have 26.15 Newton, and for the total component force in the y direction, 34.61 Newton. We square them both and find the square root of both value added. And lastly, we need to find the direction of the total resultant force. We use the trig ratio for calculation. So the formula is theta equals to the inverse of tan times resultant Ry over resultant Rx. We then plug in our values in the formula and we got an answer of 52 degrees. So guys, we made it to part 3 of the video. So let's resolve these forces into their vector components. If you notice, for A, the angle is not measured from the horizontal. So this is easy. What we now need to do is to minus 80 from 90, and that will give us the correct angle to work with. So for A in the x position we do minus 16 cos 10, and that equals to 15.76 Newton. For B we don't have any force acting in the x position, so we leave it out. For C we have minus 65, and we need to find the angle from the horizontal axis for it. So we just minus 25 from 90, and we got 65 degrees. And for D we do 28 cos 50, and that gives us 17.99. After working out the total component force we got minus 56.68 Newton. And now we need to work out the component forces in the y direction. For A we do 16 sin 10, which equals 2.78 Newton. B is at 90 degrees, so we place 11 in the table. If you should try it in your calculator, you would then notice the sin of 90 is 1. At C negative 65 sin 25 equals minus 27.47 Newton. D is measured from the horizontal axis. So we do minus 28 sin 50, and that equals to minus 21.45 Newton. And the total component for the force at Y is equals to minus 35.14 Newton. Finding the resultant force we get 66.69 Newton. And after working out the angle we got 31 degrees. If you have any question relating this topic, please to leave a comment and we will definitely respond in no time.